Hello there. Welcome to another quiet journey through a subject that keeps physicists up at night and hopefully helps you drift off into sleep. Tonight, we'll be exploring the softly glowing edges of reality. Quantum physics, the science of the small, the strange, and the utterly baffling. So close your eyes, settle into your pillow, and let's fall slowly into the quantum world. Galactic. Part 1. What is quantum physics? Quantum physics is the study of matter and energy at the smallest possible scale, smaller than atoms, smaller than electrons. We're talking about particles that flicker in and out of existence. That may be waves, or may be particles, or both. You can't see them, you can't touch them, and yet everything around you, including you, is made from them. Part 2. The puzzle of light. Long ago, people believed that light was made of waves, rippling gently across space, like water in a pond. Then, a scientist named Max Planck came along. He found that light comes in tiny little bundles, called quanta, little packets of energy. Population, population, population. This was the beginning of quantum theory, a soft little ping in the universe that would change everything. Part 3. The double-slit mystery. Now imagine this. You're firing tiny particles, electrons, at a wall. But between you and the wall are two narrow slits. You'd think they'd go through one slit or the other. But instead, they form an interference pattern, like waves. Waves going through both slits at once. But here's the weird part. If you try to watch them, if you set up a detector to see which slit they go through, they stop acting like waves and act like particles again. Somehow, just watching changes what happens. Part 4. Schrödinger's cat, the cat. Not a real cat, but a thought experiment by Erwin Schrödinger. You place a cat inside a box, along with a radioactive atom, a Geiger counter, and a vial of poison. If the atom decays, the poison is released, and the cat is no more. But, and this is the strange part, until you open the box, the cat is both alive and not. It exists in superposition, a state of all possibilities. Only when you look does the cat's fate collapse into one outcome. Part 5. Heisenberg and uncertainty. Another scientist, Werner Heisenberg, realized something just as unsettling. The more precisely you try to measure a particle's position, the less precisely you can know its momentum, and vice versa. This is the uncertainty principle, not because your instruments are bad, but because the universe simply doesn't allow you to know both. Reality is fuzzy, on purpose. Part 6. Quantum entanglement. Now for the spookiest bit. Entanglement. Sometimes, two particles become linked. What happens to one instantly affects the other, even if they're light years apart. Einstein called this spooky action at a distance. It's as if the universe is whispering between particles. Part 7. Quantum computers and tomorrow. So what can we do with all this weirdness? Well, scientists are building quantum computers, machines that don't just calculate one thing at a time. They explore many possibilities at once. They work with qubits, quantum bits that can be 0, 1, or both. It's like solving a maze by walking every path at once. It could change everything, from medicine to encryption to understanding the universe itself. Part 8. Dreams of the multiverse. Some believe all those possibilities never collapse. They just branch off. Every time a particle goes left instead of right, a new universe is born. In one, the cat lives. In another, it doesn't. And in a third, it's probably doing taxes. We call this the many worlds interpretation. One universe for every choice, every chance, every blink. Outro. You are made of quantum now. As you settle into sleep, know that you are made of these same particles. You are a quantum being. Your thoughts, your dreams, you are a pattern in the fabric of possibility. So, sleep gently, float softly, and let the mysteries of the quantum world gently tuck you in. Good night.